Welcome back for page 3. So we have a situation with a 1,800 kilogram car going over a hill that's a circle with 30-meter radius. It's asking at what speed would the centripetal force equal the force of gravity? So the idea for this one is, as we know, if we have a car on like a flat surface, it's going to be like this, where these are the same. And as we start going over a curve, we know that, so this type of curve, which is a hill, we know that this one is bigger than this one. So this problem is basically pushing us from this situation to this into an even more extreme, where basically it's going fast enough that at the very peak, the upward force just kind of disappears entirely. So we're looking at a situation where it's going pretty fast, and the necessary centripetal force, so the inward force, is going to be equal to gravity, which means there's no normal force at all. So it's like that moment when you're on a roller coaster or like on a car going over a hill where you just kind of like you get butterflies in your stomach and you feel weightless for a moment. So that's what we're looking at. So let's just calculate what that force needs to be by finding out what the force of gravity is. So then it's our same equation as always. It's just 1,800 times 10, which gets us 18,000 newtons. So that's the force that we need as the centripetal force. So then we just have to figure out what the speed is that's going to make that happen. So we can say 18,000 equals mv squared over r is our equation. So I guess I can just write out the equation again. And then I'll plug in all the stuff that I have. So 1,800, V is what we're looking for, and 30 is the other thing that we have. So my wife has her phone, so I'm gonna have to get out my old phone. I'll start by multiplying by 30 on both sides. Oh no, 18,000 times 30 is 540,000. Divide both sides by 1,800. There's 300, and now I have to square root both sides. Oh no, I think this phone's so old that it can't flip anymore. I'm gonna have to Google what the square root of 300 is. It's 17.32. So that's the necessary, I guess I'll rectangle it, meters per second. So if it's going 17 meters per second, then it's going so fast that when it gets to the peak right there for just a second, it's like a weightless sensation where there's, there's no normal force. The track is not pushing up on the roller coaster anymore. And part B says, if the car were to exceed this speed, what would happen to the car? So this is basically a situation where, in order to maintain this course, the car needs to have 18,000 newtons. And if this is exceeded, then the car has basically, more newtons is required to keep it on the track than its actual weight is. So if you just think about Mario Kart or whatever racing movies, if a car goes over a hill too fast, what will happen? And it's pretty much exactly what you would imagine, where it just sort of like, it doesn't fly away or anything, but it would not maintain connection with the road. It would sort of, go airborne for a minute until it lands back down. So the car would go airborne. I don't know if that has an E at the end. And lose touch with the road. Briefly until it lands again. I need a pencil sharpener, but I don't think I own one. So it would land down here maybe. Maybe a nice picture would be helpful. Car going this way, and then car is in the air, and car is on the track.